So this is part 2 of where we left off, and we created this core data stack class, and we added the public keyword because what public does, it means that it could only be overridden or subclassed by by classes in this file or this module. It's the whole point is to keep it secure because this core data stack is how we're handling our objects, how we're viewing them, how we're saving them, how we're deleting them. So it's important to keep this as secure as possible so we don't interfere with its process of doing this and how we could extract these values. So what we want to do first is create a singleton static let instance. We'll call it with lowercase c, and it's going to be an instance of core data stack. And the reason we create an instance in the class is so we only have one instance of this, so we never have to instantiate it more than once. Therefore, we're always accessing the same instance over and over. So we could keep pulling from this instance or just keep accessing all the values in here. So we know all the values are saved or are going through this one instance. It's all handled by this instance and the functions we add in this class. So I'm going to create a note here and say creating a singleton so that it is only instantiated once. And again, for security, so nothing interferes with the flow on how we're adding, deleting, saving these objects. So the next step is creating a persistent container. So what a persistent container does in core data is it's a way to store all these managed object contracts or all these managed objects that we're saving. So all the universities, it's a container that holds all these finished products, and the next step from there is adding them to a database or a persistent store where we're actually storing the values. So from the container, it's then shipped off to the persistent store. So the container just holds all the values once we tunnel them through the context, and you'll see when we go more in depth on that. So what we're going to do is create a persistent container, and we'll go over the context in a minute. Just bear with me. And then we're going to want to create a container. Don't mind all these errors, they're going to go away. And you're probably wondering, why are we using lazy, or what does lazy even do? This task is very expensive in the terms of like time and space complexity. So what we're going to want to do is use lazy so that it's only called or it's only executed when we explicitly called it, not when any other part of this file is called, when we explicitly call this. And that's good because it saves us time when executing anything else, that it doesn't execute this and waste our time or take longer for the user to see, because it's all about speed, right? So the persistent container name is actually going to be the name of this file, the XC data model, and we're going to go over that in a minute. But this is the persistent container is actually this XC model name, this file, so it's going to be University Observer. And then what we're going to want to do is, like I said, once it's in this container, the next step is to ship it off to a store. So what we're going to want to do is, forgot an equal sign, is we're going to actually want to get the persistent store. So by default, it's SQLite, the database that it stores to, and that's fine for us. So what we're going to want to do is we're going to want to add a completion handler. So this is called at a later time, even after the lifetime of the function ends. And we're going to want to do some error handling. So if let error equal error as ns error, we're going to want to have a fatal error. So what this does is that if there's a problem loading the persistent store, meaning if there's a problem of where we're storing all these objects, I want this app to crash, because then what it's simply going to be like in terms of the app is the user is going to keep adding universities. When they come back, they're not going to be stored. And that's just a waste of their time, because the whole point is to view it or persist it through many lifetimes of the application. So if it's not able to store, I want to have a fatal error. And what a fatal error does is it crashes the app if this error message ever gets hit, or if it goes into this block. So what I'm going to say is that there was a error loading the persistent stores. But it could also give me, but the reason we casted it as NSR is because it will give us its own error description. So I'm just going to say unresolved error, meaning it hasn't been fixed, and I'm going to interpolate the error message. So error, and then the description of that error. So we have an error, but let's see what that error is giving us. Oh, it's because I'm missing a parenthesis right over here. And I want to return that container. Every time we call it, I want to grab that container, because that's what we're going to be using to store all these objects. And okay. So the next step is creating these the view context and the background context. So let's dive more into what these contexts do. So the view context and the background context, or you could simply think of them as tunnels. Now, if you think of a highway or any place where there are tunnels, you usually have, in this example, we have two tunnels, right? We have the fast tunnel for people who pay toll. They usually go back faster. We have like the free tunnel or something that's usually backed up with more data. Now, in terms of applications, what usually goes in this view context, or the main context, or the main queue, is UI stuff. So what we're displaying on the cells, or what we're going to be using to be displayed on the cells. Just UI stuff, how we're updating and whatnot. It's less space complex, meaning it takes up less space. So if the user's going to see it, they're going to want to see it fast, right? So if it's less speed, if it takes less time to load, we're going to want to store it in there. While in the background context, we do more complex stuff like saving data or deleting objects and whatnot. It's all about how we want the user to experience the app. So view context, if the user is going to be seeing the universities, I want it to be saved on the view context so that the user could quickly see it, because that's the view context again is UI stuff, UI implementations. So let's create this. So again, it's going to be lazy because it is complex in its own way, so we don't want it to be called unless we explicitly call it. And it's going to be a type manage object context, meaning we're going to store manage objects in this context. And I probably said this before, but that's what's neat about Swift. The naming conventions aren't there to confuse you. It's simply there to it's descriptive, to say the least, no matter how long-winded they are sometimes. So we're going to persistent container. So we're calling this variable, or getting the persistent container.view context. And now we're going to return that view context. So what this essentially does is it accesses this persistent container's view context, and we're setting it equal to the manage object context we instantiated here. So it's basically creating a view context that we can access in this file. And now for the view context, we have to do the same for the private context. And it's a little different, but it's all the same end result. So this is also going to be a managed type object, NS managed object context. And then we're going to say let private context equals NS managed object context concurrency type, and then we're going to put it on the private queue concurrency type. And that's going to be on the private queue. The background or the private context occurs on a private queue. That's where we do more complex stuff like saving objects, deleting, stuff that takes longer that we don't want the user to necessarily see. Once we do that, same thing, we set the private context, their persistent stored coordinator equal to the persistent stored coordinator or persistent container rather. Where is it? Yeah, persistent store. So what this does is, and then we're just, before I do that, we're going to just return private context. So this whole chunk of code is the same thing as this. They have the same effect. This just goes more into what it does. So first things first, we're instantiating a managed object context, which is represented by the name private context. This is going to be where we're storing things that we don't want the user to see, stuff that's going to happen in the background. That's why we're putting it on a private queue. Next thing is that we take this private context. We take this private context and we grab its persistent store coordinator, meaning once it's tunneled through the private context and into the persistent container, we want to take those objects and send it to the same store as the store that's linked with this persistent container, meaning no matter where it's tunneled, whether it's the view context or the private context. Remember, these two do the same thing, just for different contexts. No matter what happens, we want to take their persistent store, we want to take those objects and send it to the store of this persistent container. Because whether it's a UI update or something regarding UI or something regarding we don't want the user to see, we want to save them in the same store, just send them through different contexts, whether it takes more time or less time. But in the end, we do want to save them in the same store to save them, so every time the user opens up the app, we could grab them and it's not held in different places. That's also why we created a singleton, so nothing interferes with how we're extracting the objects. And it is giving me an error. Oh, it's just naming. And yeah, so next things, for the purpose of this app, we're just going to be very simple. We're only going to do, we're going to have a save, and we could also add a delete after. The whole point is just to get this core data stack. And then we're just going to add a save to function. This is going to be how we're actually saving the changes or what the user is writing. So it's going to take in a parameter of context, meaning whenever the user calls this function, we want them to save it to a context, meaning we want them to perform it on a specific queue, so the app knows how to handle it and how much time it should take, and if the user should see it or not. So if the context does have changes, meaning if there were changes saved to the context, we're going to add a do block. We're going to print user has made changes to the context, and then we're going to try context dot save. And then if there is an error, catch. Again, if there's an error and it's not saving the universities for some reason, we don't want the user to keep going, and then when they come back to find that none of their universities have saved. So I'm going to create an error, and then I'm again fatal error because we want it to crash if so. Fatal error, and then it'll give us the error. So I'm just going to write an error message. And interpolate the description. Okay, that's it for this video. We wrote the core data stack. Feel free to ask me questions in the comments. Part 3 will be coming shortly after this. But if there are any questions, again, be sure to ask. I know core data is a very confusing topic, but once you get used to it, you won't really need some of the more complex stuff unless you're handling more complex app. But really, this is the bulk of the most simple version of core data, what we could use it for to save and persist values. So yeah, feel free to ask me any questions. Thank you.